So, carbon 14, the radioactive element of carbon, decays according to the normal formula P equals 100 plus 999.88, where P is the percentage of the original mass of carbon 14 that remains. Find the percentage of carbon 14 that remains after 200 years. Okay, lads, very simply, you get your calculator out and you replace the n value with 200. Can somebody call me out the answer for that, please? What you get? 0.97. And what decimals did you tell me? 7.6. Yeah, that's it. 0.976 or 97.6 cents. Anybody else got that answer? Alright. Next one we're going to do to the power of 500. So I'm to the power of 500, lads. What are we going to get then? And any takers? Louder. 94.2. Alright. So 0.942, which is 94.2%. Happy days. Everybody cool with that? Estimate using trial and error how long it will take the carbon 14 sample to decay to have its original mass. Give your answer correct nearest 10 years. Would you even think it's anywhere close to, is it even anywhere close to 50%? Is 94 anywhere close to 50%? No. So here's what we're going to do. We're going to get our good old friend the table function. Okay. And we're going to put in this amount here. Oddly enough, I could have used logs to do it. I might actually show you that in a second, just purely because we have that exercise done, or we're doing it. Alright, ready for this? I'm going to start at, 0. I'm going to end I'm going to go up in gaps of, let me see, I'm going to go up in gaps of 2,000. So I'm going to stop at 20,000. I shall go up in gaps of 1,000. Let's see what happens here. Right, looking for 50%. No. Ah, there we go. Somewhere in between 5,000 and 6,000. What am I going to do now? Start again, and what am I going to do this time? Start at 5,000. End at 6,000. And I'm going to do gap of 100. 100, okay? Find out. Keep going. There we go. Alright. 5,700 to 5,800 is that gap there. And then if I'm really precise, which I usually am, I'm a bit OTT about stuff, I go back in here again. I now do 5,800 to 5,700 to 5,800. And I do a gap of 10. Go again. When am I going to be on 50% on the money? Up. Like a glove. Somewhere like, call it 5,770, somewhere around that. I could go again, couldn't I? Until I'm ridiculously accurate. Like if you really want it. I'm just slowly zooming in on what I want. I'm going to go step of 1 this time. And I'm going to get it. I'm going to get it on the money, like it's only a matter of time. Oh, look at that. 49.999. You'll take that, won't you? Now, they don't need to know how you did it. But what's the only thing you need to do? 100 into 0.99988. And then what do we have here? What's that? 577.6. And the answer to that will be 0.499999. Which is approximately 50%. Is that okay? Now, I'm about to show you a different way of doing the same question. You ready for this? Alright. So, this way, I wouldn't have been able to teach you this without the logs. Does anyone remember the other day a log rule I told you? What can I do with the power? If I have like a 10 to the power 3, what can I do with that power? I can move it to the front and I can call it 3 log 10 base 10. Is that okay with you guys? So I'm going to show you a little trick here to get the exact same answer we just got here. Here's the trick. It's going to be 100.99988 is it to the power of n, isn't it? Yeah. And that equals p. What does I want p to be equal to again? Would everybody agree p equals 0.5? Everybody cool with that? No. Here's what I'm going to do next. 0.5. Everybody cool with that? Divide by 100. I'm going to divide 0.5 by 100. 0.5 by 100. Anybody? Same thing as 5 over 1,000. Is that okay? Now, everybody knows my answer is going to have something to do with logs, don't you? So it's 0.5 divided by 100 equals 0.5 divided by 100 is 1 over 200. 1 over 200 is 5 over 1,000. Same thing. Alright, here's what we're going to do. And we're going to be doing this later on today anyway, so we might as well do it now. If you have a variable, if the variable you're looking for is in the power position, see the way it's in the power position? You can choose a log of any type you want. You can use log base 2, log base 5, log base 10. I pick log base 10 because it's default. And here's what we're going to do. We're going to log both sides. Okay? So you're doing the same to both sides, which usually means nothing's affected. What happens to the n? What happens to the n, lads? It's in the power position, so what does that mean I can do? There you go. N log 10 by 0.99988. Anybody have any clue how to get the n on its own? How do you get the n on its own, lads? The n is being multiplied by this thing here. So what am I going to do with that? Yeah, take out your calculator. And what I want you to do is do log 10, 5 over 1,000 divided by this log here. We know the answer, don't we? It should be roughly 5,776. If I don't get that answer, something's up. For those of you who are struggling with the calculator, just press log and then 5 over 1,000. And then on the bottom, log 0.99988. Oh dear. Totally should have came out like that. So that says 44,149. Interesting. Alright, let's find out. Alright. Then we have the... What? That is miles off. It's not even close. Alright. Let's go again. When I did the original question, it was when I did the original question, I hate when something that works and it should work, and I've done 100 times before, should work and it doesn't. And there's always a little reason. So something was taken down wrong, or something was. So we said the answer was 5,000 and something, didn't we? 5,700. Right, let's find out. Step of 100. We want 50%, don't we? And this table function tells us that the answer we were looking for was 5,776. So I did it in depth earlier, didn't I? So somebody see the mistake I made? Brian? Did what in decimals?
0.5 0.5.
Yeah, but I did do a 0.5. Oh, I see it now. It's actually giving me out the percentage, not the decimal. So in that case, thank you very much. There's your error. it doesn't spit out 0.5, it actually spits out 50. Is that okay? And then, so these decimals never should have happened in the first place. They're just the percentage answer straight away. So that means that this is no longer, this is now, 50 over 50 divided by 100. So do exactly what we did earlier, except this time it's 50 over 100. So go back to your calculator. This time do 50 over 100. What you get this time? That's what I'm talking about. 5,775. It works to perfection. It has to work. Okay? Thanks for spotting that, Brian. Now, what's the next question after that? A bone containing 79% of its original carbon-14 was discovered in a bog in County Offaly. Estimate its age. Question. We now have the power of logs. Do we even have to estimate its age, or can we find it directly? Now, it does say estimate, so I'd go back to my table function, and I'm looking for 78, haven't I? So let's go back for a second. Let's start at, 3,000. Let's end at 5,000. Let's go up in steps of 100. I'm looking for it to be 78. I'm too high, haven't I? So maybe start at 1,000 and end at 2,000. Let's go again. Oh, did I just delete that? Yes, I did. 0.99988 to the power of x. Alright. Start at 1,000 and at, 3,000. Let's see if it works this time. Step of 100. Is 78 in this one, lads? Can everybody see 78%? Where is it? Somewhere between 2,000 and 2,100. Everybody see that? Then you narrow in one more time. 2,000. You'd be surprised how many times you'll do something like this in a Leaving Cert exam. You can find stuff out instantly. So again, I would estimate 2,070. Is that alright? So how do I get my workings how do I show my workings in the exam? Just rub that out and put in what? Oh, sorry. Rub this out, and what will I replace in here? Replace n with 2,070. And what's the answer in the back? Then the answer would be 78%. Is that okay? If you're doing logs, how would you do it? Lads, if you're doing logs, what would you do? Change this to 78. What? Oh, so 79. Oh, perfect. Alright, let's go back. Alright, so below 2,000, yeah? So, thanks. 1,500 up to 2,000. How long does it take to get to 70? Range error, that means my step was too small. So 100. Go through your numbers again. Hopefully you get 79 on the money. 79 on the money is somewhere between 1,900 and 2,000. Go again. Don't know how you'd guess it. Like, so 1,900 and 2,000 steps of 10. There we go. It's probably 1,965, something like that. Is that alright? Everybody cool with that? Now, more accurate than, you won't be doing that anymore because you know how to use logs, don't you? So what would you do instead? You put your formula equal to, anybody? Your formula gets equal to 79, is that correct? What's the next step? Bring the n, log both sides. No, we don't log both sides just yet. Excuse me. See that hundred? What do I do with the hundreds? The 100 on the left goes below there. And what does it become? It becomes 0.79. Now I log both sides. Now what happens when I log both sides? Anybody? Comes to the n. N travels to the front. And I still have log 0.79 over the other side, don't I? Now what's n on its own then? N on its own will be log 0.79. Log 0.79 divided by log 10.9988. What do you get as your answer when you put that in? And that's what we're expecting, wasn't it? If you look at our table function, somewhere between 1960 and 1970 was the answer we were looking for, and we got 1964 doing that right there. Okay, it's much better. Now, it's a good thing we did that. Now, let's go to question 8. And that's how to use carbon dating for historical items. Now, alright guys, a science researcher is monitoring the world's most dangerous animal, the mosquito. And he actually is the world's most dangerous animal. What? Yeah, because they kill more humans than any other animal. Yes, via malaria. So when they bite you, there's a good chance you have malaria. And if your country doesn't have the antidote for malaria, you die of malaria. So they're much more lethal than a shark, wild tigers, hippos, buffalo, you name it, mosquito or king. Okay? Interesting fact for you. Bats are closely are starting to win that though. I think maybe the bat is number 1 now. Who knows? Alright? Now, a science researcher is monitoring mosquito plague notices that the area affected by the mosquitoes is given by this function here. Find the original area affected. So the original area affected will be week 0, no time has passed. So what do you need to put in there? A0 equals 100 times 2.02 to the power of 0, 1,000, thank you. And is 1,000 the answer? It is, yeah. Now, once again, I'm going to be quite lazy here. What am I going to do? I'm going to go to my beloved table function. And I'm going to put in 1,000 multiplied by 2 to the power of 0.2 x. I'm going to start at 0. I'm going to end at 20. I'm going to do steps of 1. Now I can read off my answer for 5 straight away, can't I? Where's the answer for 5? Answer for 5 is 2,000. So A5 equals 1,000 multiplied by 2 by 0.2 to the power of 5, which equals 2,000. Alright, what's A10 then? And we got the answer for A10. 4,000. And finally, A12. 5,000. 5,278. Okay. Next thing I'm going to do is going to draw a graph, aren't we? What points do you have? You have 0, 1,000. What else do you have? 5, 2,000. You have 10. You have 10, 4,000, and you have 12, 5,278. Logs are generally what shape? Logs are usually linear, so you can just draw 2 points and draw them together. Let's find out. Let's hope this works, okay? Can somebody call me out the equation in a second, please? For question 8. Really quickly. Alright. What is the equation for question 8? What'd you say, 1000? So 1000 multiplied by 2. Oh, sorry guys, this is an exponential function, not a log function, so it's not going to be a straight line. Is it 0.2x or 0.02x? Yeah, anything else? Alright. Why is there nothing on my graph? Why can't I see anything? Where does it start at? Yep. Now, it looks sort of like a straight line, but is it? I'm going to bring this in a little bit. No, it's a curve. Definitely a curve. It's a very gradual curve, but it's still a curve. Ever see that? It sort of resembles a straight line at the beginning, but when you bring it in, the further you bring it in, the more you realize it's actually a curve. Okay? Be careful with stuff like that. Now, who got that graph out? Alright? So the graph you're looking at is this your graph here. Alright, does that ask us to do anything with the graph? Just ask us to draw it and that's it. Alright, done. That's your answer. Happy days. Alright, yeah. Shouldn't it? Alright. Can you read the question now again for me?
You got 0.0,
Oh, 0.2. My fault. Guys, go again. Ah, much better. Now, sorry guys, the equation was read out slightly wrong. Did anybody get something like this instead? A curve. Alright. And what Killian said is true. You should have 12 5,200. So this is actually the graph we're looking for. So our biggest enemy seems to be not reading the question properly, okay? So that is questions 8 and 9 done. Alright guys, and we're done. That's it there. Alright.